So in this video, we're going to do a limit problem. And the first thing that I always do with my limit problems is I check the form. Okay, so to check the form, I'm going to plug in 0. And so whenever I plug in 0, I get the tangent of 0 over the natural log of 1 plus 0. Tangent of 0 is 0. ln of 1 is 0. So my form is 0 over 0. That means I can use L'Hopital, so I'm going to use L'Hopital's form or theorem now. And so with L'Hopital's, I'm going to take the derivative of the numerator and take the derivative of the denominator and evaluate the limit as x goes to 0. See, it's still staying the same here. So what is the derivative of tangent? It's secant squared. What's the derivative of natural log of 1 plus x? Well, that's 1 over 1 plus x times the derivative of 1 plus x, which is 1. Okay. Now, whenever I plug in 0, what do I get? Well, if I plug in 0 for secant squared, remember secant squared is 1 over cosine squared, right? So if I plug in 0, what is that going to get me? Cosine is at 0 is actually 1, right? So 1 comes 0, so the cosine is 1. And then I plug in 0 there. So that's going to get me 1 over 1 squared, and then 1 over 1. So that's just 1. So my answer is 1, okay? So what is that basically telling me? That's telling me if I'm looking at the ratio of two functions, I'm thinking about growth speeds, and my ratio is 1, that's telling me that tangent x and ln 1 plus x are growing about the same growth rates. It's kind of what that's telling me at x equal to 0. They're traveling at about the same speed, okay? So, as far as the magnitude is at infinity, you'd have to take the limit as x goes to infinity to figure that out. Now, let's try another one. Let's do an infinite limit one. So limit as x goes to infinity of e to the x over x to the 4th. Now, two ways you can do this. One, you can note that the numerator is an exponential and the denominator is a polynomial. And so since we're traveling to infinity, what do we know? Well, an exponential travels quicker than a polynomial, right? So therefore, the numerator is going to get bigger faster. So I know that my final answer should be infinity. It should be, but let's use L'Hopital to figure it out. Why do we know we can use L'Hopital? E to the infinity over infinity to the 4th power, that's infinity over infinity. That's the form. Okay, so I want to see you write that form right there. And now you can say L'Hopital it. So if limit is x goes to infinity of e to the x over x to the 4th. L'Hopital, limit is x goes to infinity. Well, what's the derivative of e to the x? Well, it's e to the x. What's the derivative of x to the 4th? That's 4x cubed. Now I'm going to see that that's still form infinity over infinity. So I'm going to L'Hopital again. So take the derivative of the numerator again. It's still e to the x. Derivative of the denominator. What's the derivative of 4x cubed? That's 12x squared. Once again, the form is infinity over infinity. If I plug in infinity, I'm still infinity over infinity. So I'm going to L'Hopital again since it's indeterminate. And once again, e to the x in the numerator. Denominator is 24x. What do you notice that's happening to the denominator? Each time I take the derivative, I get 1 power less stronger. So looks like one more derivative and we're going to be to where we're not infinity over infinity anymore. So the limit is x goes to infinity of e to the x over 24. And so now I get infinity over 24, which is infinity. which, that was exactly what I was thinking that it would end up being. So all's right in the world. All right. Now, if you think back to Cal 1, there were a couple of special trig limits that I told you to memorize. Now we're going to show you why these work through L'Hopital's rule. Limit as x goes to 0 of sine x over x. Now, if you remember what this equals, that's great. If you don't, well, what happens whenever I plug in 0? When I plug in 0, sine of 0 divided by 0, so that's 0 over 0. So the form 0 over 0, so I'm going to L'Hopital it. The derivative of sine of x is cosine of x. The derivative of x is 1. Now whenever I plug 0 in for cosine, I get 1 over 1, which is 1. So that proves this definition here. Limit as x goes to 0, sine x over x is 1. Okay, so something that you had memorized, now you can actually solve. Okay. And then limit as x goes to 0 of 1 minus cosine x over x. All right, so once again, when I plug in 0, I get 1 minus cosine of 0 over 0. So it's 1 minus 1 over 0, 0 over 0 is the form. Since it's indeterminate, I'm going to use L'Hopital. Limit as x goes to 0. Well, what's the derivative of 1? That's 0. Derivative of negative cosine is sine over 1. Okay, so derivative of x is 1. And so what does that give me? That's sine of 0 over 1, which is 0 over 1. Oh no, is that undefined? No. If I divide 0 by 1, then I get 0. Don't believe me? Put it in your calculator. So what does this tell me? It tells me that identity that we had in Cal 1, limit as x goes to 0, 1 minus cosine x over x is still equal to 0. Okay, so now you don't have to memorize those anymore. You can use L'Hopital's rule to get your answer. Okay? It's always great whenever I get my Cal 1 students turning in work and they're using L'Hopital's rule, and I'm like, not sure you've learned that one yet. So be careful, right? Okay,